give it a moment for things to kind of boot up. I'll leave that be. And then here, and let's go ahead and let me check one more time. Let me get the student. One more check. Okay. Uh-oh. Okay. Start the broadcast. All right. So we're ready to rock and roll. Let's see if there are any major announcements. So this brings us to the end. Welcome, scholars. This brings us to the end of week 5, right? So we had exam 1 due at the start of this week, and we're just kind of continuing where we left off with with chapter 3. So we can anticipate exam 2. The rhythm pretty much goes 3 weeks of lecture, 1 week of exam, 3 weeks of lecture, 1 week of exam. We pretty much do that rhythm all the way into the end. So this is the first of 3 weeks before exam 2, right? And exam 2, you can anticipate it to be over, I think, this chapter 3, right? Let's see. Okay, I can't think of any other pertinent information. So we're just gonna kind of continue with the homework left off from last time. So I'm under the impression we got through 13 questions. So we have maybe 11 questions today, maybe 12. But if we, depending on when we finish and how long it takes us to do it, we'll see about how the end of class goes. So here we asked to find the domain of the following function, right? So for a log function, as a quick recap, the graph of the log is going to be basically, it kind of starts off vertical, coming along the y-axis on the right-hand side of the y-axis. It passes through the point 1, 0, and then it kind of veers off to the right. It doesn't flatten out or anything. It just kind of gradually keeps increasing to the right. So hopefully you can get that image. So long story short, in general, the domain for a log function is 0 to infinity, the open interval 0 to infinity. So we can't take the log of 0 and we can't take the log of negative numbers. So long story short here, that square root of x minus 3, that part has to be strictly greater than 0, right? So to find this domain, we just set that part strictly greater than 0, right? The square root of, I think it was x minus 3, has to be, I don't know why my pen is doing that. That's irking me. Lay down. Lay down. Come here. Because your pacing is driving me nuts. Lay down. Lay down. Get down. Come here. Go to bed right here. Go to bed. That's better. Thank you. Okay. Square root of x minus 3. Just rewrite this. I don't know why it does that. Okay, so again, this thing has to be strictly greater than 0. Okay, so then if we solve for x, we square both sides, we get this, right? X has to be strictly greater than 3. Right? In interval notation, so if we're talking about x is strictly greater than 3, if we consider the number line and we look at the graph of x equals 3, right? If x is greater than 3, are we talking about all the numbers to the left of 3 or all the numbers to the right of 3, right? So if x is greater than 3, that means we're talking about all the numbers to the right of 3, right? And because there's no bar, that means we could use a parentheses. So here, basically, this is set notation. And then this line is the graph, but they generally want the solution in interval notation. So from the graph, the solution set, we're talking about from 3 to infinity. Infinity always gets a parentheses. And again, in this case, because there's no bar under the inequality, we're going to use a parentheses. If it's not clear, just feel free to unmute yourself and get my attention so we can discuss it. I think it was this class last time someone had a question about the homework, and then we got to end the class, and I guess either they zoned out or they disappeared and they forgot. But I couldn't, they weren't there, so.
Someone's there in the waiting room.
Yeah, I'll check it again in like 3 minutes. So yeah, I usually do it like as soon as I get in, and then I try to check it again around the 15-minute mark. So I'm gonna give them a couple more minutes just to get people trickling in. But thank you for the reminder, the notification. Let me see. So we said 3 to infinity, right? The open interval, 3, comma, infinity. Okay. Let's see. The figure on the right shows the graph of log base 3 of x. Use the transformations of this graph to find the graphs, to graph the given function, and then find the graph's vertical asymptote, domain, and range. Okay. What is the graph? So, in general, the log function, it looks like what you see on the right-hand side of the screen right now, right? So then now the only transformation that we did, we added a 5 inside the basic function. So inside manipulations typically cause a horizontal change. Let me see if we add, and it's usually the reverse of our intuition. So if we add 5 on the inside, that should cause the graph to shift to the left by 5, right? It's the reverse of our intuition. You would think that positive will go to the right, but it actually goes to the left. When you're working inside manipulations, a lot of times it helps if you consider what value of x makes it 0. -5 makes it 0, so we go to the left. I'm gonna go C. That's the only one that moved left. As soon as I finish this one, I'll check the attendance. The vertical asymptote. So normally the vertical asymptote is the y-axis, which is x equals 0. But since we went left by 5, so now the vertical asymptote is x equals -5. Okay. Usually the domain is 0 to infinity. Because we went to the left by 5, it should be the open interval from -5 to infinity. The log is the very bottom to the very top. So that's going to be infinity to infinity. And let me see, let me hit edit. Did we finish? Yeah. Let's see, the student, got him, coach. Came in. I'll take attendance like when I first joined. Just because what I noticed was, my headphones disconnected. Okay, give me. Save. Yeah, because it would kind of like take away from a lot of time constantly. Because I have to hit save. If I don't hit save on the attendance, then I did like lose one attendance one time. I was like, oh, gotta save. You heard about the typing contest between Jesus and the devil, right? Yeah. So this is a PJ. Just brace yourself. It's bad joke time. Okay, PJ stands for poor joke. So the Jesus and the devil were in the typing contest. I mean, and it was fierce. Like it was going on for like days and weeks and months and millennia. I mean, they were typing like fierce, and it was head to head, neck and neck. 1 minute, Jesus in the lead, and then the devil would catch up, and then they kept going back and forth, back and forth, back and forth, and then the power. But you know who won, right? Jesus. Okay. Bad joke. Okay. Had to. Couldn't resist. But I gave you fair warning. Okay, let's hop back over here. Let's see. So it says, for the following function, briefly describe how the graph can be obtained for the graph of the basic log function. Then blah, blah, blah. Graph the function and set the domain. Okay. So again, more transformations, right? So the transformations were from College Algebra 1. Describe how the graph, so we take the basic graph, the basic shape of the log function, And then the only transformation we did was we subtracted 2 inside the basic function. That -2 is inside the parentheses, right? So again, inside manipulations generally cause a horizontal change. If we subtract 2 on the inside, that's going to move it to the right by 2. So move it 2 units to the right. Shameless marketing for like these different shows. So I've recently watched, what is it called? What is it called? Peacemaker on HBO Max. It was fun. I enjoyed it. You know, it to me, and they have the series season finale like next week. But it's like it to me, it felt like the long version of the movie. So if you like the movies, you more than likely would like the TV series. It was fun. Let's look at this one. I think we got more. So we want a graph. So the log function, right? So log is the top right in this case. The bottom left is the exponential. Exponential kind of starts off flat and then takes off vertically, or not vertical, but near vertical. But then the log function starts off near vertical and then kind of goes off to the right. So if we're graphing log, I'm going to click on that tool. It says click to plot the curve. So just click it anywhere on the graph. Now the only transformation we did was that -2 inside. So we said that moves it to the right by 2. So horizontal shift to the right by 2. I just slide the thing. The base is already set to 3. I think we're good. Can I just enter? Yeah, we shifted it to the right by 2. We're going to hit save. Let me check Zoom really quickly. Wait, there's more. What's the domain, right? Okay, so in general, the domain of a log is 0, the open interval 0 to infinity. But because we moved it to the right by 2, it's going to be the open interval from 2 to infinity. So 2 to infinity. Every time I say infinity in my mind, this is more marketing. This is, I mean, I'm totally brainwashed. It's so bad. But like every time I say infinity, I think of Toy Story because I'm thinking to infinity and beyond. And like they're coming out with that Buzz Lightyear movie. So I was like, oh, that's kind of interesting. The vertical asymptote is x equals 2, right? X equals 2. And again, oh, wait. They already got the x there. If anything is not clear, just stop me and we can talk about it. Let me check Zoom really quickly to see if there's like any notifications there. The chat looks good. Okay, we do have somebody. Okay, let me let them. Edit. Let me check my list real quick. My name does sound familiar. Right here. Okay, so we're asked to graph this function by using transformations, starting with the generic log function, and then say the domain of range. Okay, so I'm going to click to enlarge the graph. So now this one, we have this log base 1/8 of -x, right? So I'm going to choose my log tool, which is third row on the right. And let's see, it says click to plot, so I just click. The base is 1/8. 1/8. So now generally the log starts off kind of nearly vertical and then veers off to the right, but that's when the base is strictly larger than 1. When our base is between 0 and 1, instead of increasing, it's going to be decreasing, right? So let's just look at that first. Let's edit. So when the base is between 0 and 1, we have a log function that behaves like this, where it's steadily decreasing. And then to capture that negative, we multiply the inside by a -1, right? So inside manipulations cause a horizontal change. So, you know, you should notice the repetition that's going on. Like I'm intentionally saying this stuff to like, that's how you learn math or anything really. Again, math is all about pattern recognition. And so you kind of like, a lot of times it's the same concept over and over and over. And that repetition is how you learn it. If you don't get your reps in, you're not going to be proficient. You won't know it. So I know it's tedious and it's monotonous for me to say it, but if you're constantly doing that, then you learn it. It's like brainwashing. That's how I learn a lot of things. Anything that I want to be good at, I just do it over and over and over and over. And then you get it. So when we multiply the inside by a negative, and because of that, like because everybody's time is so precious, is why I don't necessarily agree with making everybody take this stuff. But that's not the thing that everybody agrees on, and that's not the society we live in. If it were up to me, I would just have everybody. What is it that you want to study? Okay, let's walk that path together. Everybody doesn't need this. Just let the people that want to know it, let them do it, and then that way they get a specialty and it makes them valuable. Like when you know this stuff and other people don't know it, then that gives you an edge, right? But everybody doesn't want that edge, right? And it's not for everybody. So I never really agreed with making everybody take this. I would be more so let those people that value it and see it, let them take it. And then when people see the value and they want to learn and they actually ask to know about it, that's when they're ready to learn. But forcing people to learn this stuff and they're not feeling it, I'm not about that. But that's not my place to say, right? I'm just here as a facilitator, really. That negative x, so it's going to cause a horizontal change, right? So when you multiply by a negative, it flips over one of the axes. Since we multiplied the inside by a negative, it flips horizontally over the y-axis, right? So just trying to get the menu to pop back up. Come on. You basically got to click on the graph. There it is. I just had to click it a million times. We flip over the y-axis, right? We multiplied the inside by a negative, and this is what we get. Let's hit save. And let's go with that. Let's see what happens. Check. Okay. Let's see, state the domain and range. Okay, so the domain, right? Normally the domain runs from 0 to infinity, the open interval 0 to infinity. But in this case, because we flipped over the y-axis, now the domain is running from negative infinity to 0, the open interval. So double parentheses, negative infinity to 0. The range for a log in general is negative infinity to infinity. So when we change the base to a number between 0 and 1, it still remains negative infinity to infinity. So this range is all rails, negative infinity to infinity. The vertical asymptote, we did not move it side to side and all, so it's going to be x equals 0. Let me see. And so again, to me, I prefer this system because, I'm able to reach pretty much anybody in the world with this. And then you can always take, because if you ask me whether I'm in person or any other time, I'm pretty much going to say what I'm saying now, right? And so there's no need for me to physically come out to some place because I'm going to say the same thing. Now, I get the whole thing about the presence. I get that. And I do acknowledge there is some level of it's different when you're in front of somebody, right? Because their presence, there's something about the presence of another being you can acknowledge it. But again, on my end, I am going to be saying the same thing, right? If you ask me whether I'm in front of you or you ask me remotely like this, I'm going to say the same thing. I might try to change it up a little bit, but and so it's just I don't know. So I say that because I prefer this way better because it's a recording. You can access it, you can pause it, slow down, rewind. As you work through your questions, you can always pull this back up and just mirror it. Let me see, briefly describe some more transformations, right? So all we did was add 1 on the inside. So that's an inside manipulation. It's going to cause a horizontal change. It's going to be 1 unit to the left. 1 unit to the left. Okay. Graph, it's just going to be the generic log function that's shifted to the left by 1. So I'm clicking anywhere, but the base is already 2, and we're moving it horizontally left by 1 right here. Left by 1, this looks good. Let's hit save. I'm going to check. Then it says what's the domain. Again, for log, normally the domain runs from 0 to infinity. So we went left by 1. Now it's running from -1 to infinity. And again, if anything is not clear, just stop me. Hopefully we're all aboard and we're not all bored. Type your answer. The vertical asymptote is x equals, in this case, -1. Okay. Use the graph of this. So we're asked to graph this log function. We have two transformations going on. There's that +2 on the inside and that +5 on the outside. So I'm going to click to enlarge the graph. The log tool is the second row right. So yeah, that's the log tool. After selecting that, I'm clicking anywhere on the graph. Now, when we do multiple transformations in one equation like this, the recommendation is work your way from the inside to the outside. So if we start with the nested most set of parentheses, we have that +2. That the inside transformation or manipulation tells us, usually causes a horizontal change and is the reverse of our intuition. So this says to go left 2, and then that +5 on the outside says to go up by 5. So we go horizontal left by 2, and then vertical up by 5. Then that's it. 4, no reflection like that. We went left 2, save, and check. To these. How many more we got? Let me check Zoom really quickly. Is there any notifications? Nobody's in the waiting room, and the chat looks clear. We're going to keep it moving right here. Okay, so evaluate this without using a calculator. Okay, let's take some notes. We're going to write this one out. So let's. I'm just going to do it the way that I see it, and the way I did it earlier worked with my earlier students. If I can get this to respond. The way I did it with them, this is the same thing with you all. Also, it is a good idea to be subscribed to my YouTube channel with your notifications turned on. I know that sounds like a shameless plug, and it is, but so that way when I go live, you can at least know that I'm going live, and you can see the topic. So then, you can either listen in and chime in, or you can you can just, so you're at least just aware of the things that I'm posting. But so that way, if you ever have a similar question, you'll know where to find this material. So now what we're going to do here, we're going to evaluate, this is basically what composition of a function within a function. I'm going to start with the innermost function. I'm just going to isolate it and do that one first by itself, and then come back and solve this, and plug that back into the other one. So if I isolate log base 3 of 81, I'm going to set that equal to y. All right. And what I'm going to do is go ahead and rewrite this log as an exponential. So I'm going to swing the base of the log and use it as the base of the exponent. So then we have 81 equals 3 to the power of y. So from here, we want to see, can we write the left-hand side as a similar exponential expression with the same base? So I think we could say 81 is 3 to the power of 4, right? Because 3 times 3 is 9, 9 times 9 is 81, right? So then these two exponential expressions are equal to each other if and only if the exponents are equal, namely y equals 4, right? And that is really this guy, the purple, right? So then we can take that and plug it into the outer set. So we have log base 2 of log base 2 of 4, right? So then we can do the same thing again. I'll do this one. We could do oranges. I'm going to set it equal to y again. All right, and do the same thing. Nope. I don't know how I did that. Oh, is it like pull up from the? They always do features. So that's a random note. And we're going to rewrite the log as an exponential, right? Just like we did the first part. So we're going to swing this. That the base of the log is going to become the base of our exponent. Okay. So then when we do this, we get 4 equals 2 to the power of y. So then 2 squared equals 2 to the power of y. And then y equals 2. So long story short, we're saying that the final result here is 2. And then now we can check. we can check this in the calculator before we submit it. It doesn't, I mean, I know it says to do it without a calculator, but it doesn't mean we can't check it with the calculator. All right, so let's see if we can get this going. Not that one. How do I pull up this one? Is it even there? It must have been. This one. Okay. So now if we wanted to check this in the calculator, let's do the following. So we're going to say log of, now the innermost set is going to be what? The log of 81. Now to do the change of base, what we do is we say divided by the log of 3. That's the change of base form again. In the calculator where it says just log, that's common log that has a base of 10, right? But if we want to change the base from 10 to a different base, we say divide by the log of whatever base we want, right? So then we're going to say parentheses divided by the log of 2. Okay. Okay. That one. Two here. Okay. A solid 10 minutes. 10 minutes. Let me see. Let's just keep going. Evaluate without using the calculator. So exponential and natural log are inverses of each other. So they essentially just cancel each other out. And this one is just 118. Graph the natural log of x plus 6, right? So this is still the generic log shape. So this, in this case, is going to be row 2 on the left. We're going to take that one and click on the graph. The base is already e. So natural log is nothing but common log base e. Now we added a plus 6 inside the base function, right? So if we add 6 inside the base function, that's going to move it what? To the left by 6. So horizontal shift, I'm going to type -6 here because we want to go left by 6. That's the transformation. To save. Graph the asymptote as a dash line, and then, okay, so we need to include the asymptote. Actually click here. So the vertical asymptote is going to be x equals -6. So I'm clicking on my line tool and I want a dash line. And I'm gonna click 2 points on that vertical line. That's not one of them. There we go. This vertical dash line that you see. Hit save. The vertical asymptote, x equals -6. -6. So in general, the domain of the log is from 0 to infinity, but we moved it left by 6. So that means the domain is going to be -6 to infinity. Okay. What's the range? All rows, right? So in general, the range of log is all rows. We only moved it to the side, so that doesn't affect the range at all. So we're going to say from -infinity to infinity. Well, this one, we're still working through transformations. We have the natural log and we have 2 transformations that are on the outside of our base function. So again, if we work away from the inside to the out, there are no manipulations on the inside of the base function. So then as we work our way out, the first thing that we come across is that negative. We multiply the outside of our base function by negative. So outside manipulations generally cause a vertical change. So this should cause it to flip vertically over the x-axis, or reflect across the x-axis. And then we added 9 on the outside. So that's going to cause it to move up 9 units. Move it up 9 units. They just have to catch my attention and stop me. We can talk about it. The log tool is this guy. I'm just looking on the graph. We got our base of E. We said flip vertically over the x-axis. So then this one. And vertical shift up by 9. We're almost there. Let's see. In general, the domain of log is 0 to infinity. We did not move it side to side at all. So this domain is still 0 to infinity, the open interval, 0 to infinity. The vertical asymptote is the y-axis, which is x equals 0. How long does it take for a deposit of $1,300 to double at 8% compounded continuously? So since we're doing exponential growth in the form of continuous compounding, and we're talking about doubling, we have this shortcut for like a doubling time and a half-life time, right? Basically, to remember that, I remember it as KT equals the natural log of 2. So the rate times the doubling time equals the natural log of 2. So then if it says how long, we can solve for t by dividing both sides by the rate. So long story short, we're going to do the natural log of 2 divided by the rate. Let's go ahead and do that now. So, and if I need to go further into that, just let me know. The natural log of 2 divided by that 8% is going to be 0.08, right? So this gives us the year. So we have 8 years. We need to convert that 0.6643 blah, blah, blah to days, right? So first what I'm going to do is drop off the 8 by subtracting 8 so I can isolate that decimal. Now, if this is years, to convert from years to days, we multiply by 365. So I'm going to say that times 365, and that'll tell us a number of days. So 242 or 243. If you did rounding, it would be 242. Let's see. 242. Let's see if it accepts that. If it doesn't accept that, we'll do 243. Then, we might be screwed. I think that was it, right? So maybe 5 minutes sooner than I would have liked, right? But that's okay. We got a little bit early. Okay, I can't really think of any other announcements. So for next week, we'll just continue with the next section. Again, my recommendation. So we're rapidly approaching the halfway mark. This semester is going to be over before you know it. You're going to blink your eye and it's going to be over, right? So with that being said, my recommendation: do the best you can to try to get ahead. If you can finish all that homework and quizzes early, you'll be sitting pretty. Because then at that point, all you would have to do, you'll just be looking for my exams and just getting your daily attendance credit, and then you can move on with your life, right? So are there any burning questions before we part? Let me go ahead and share a copy of this and send it with you guys. I think I can go right there, send a box. Should have put the other screen. Okay. If there aren't any burning questions, we're going to end the session here. And from one beautiful mind to another, enjoy the rest of your day. Okay, guys, take care. Peace.